We're diving into some AI research today. It's this whole concept of task superposition and how it relates to LLMs, those large language models everyone's talking about.
Yes. We're talking about AI handling multiple complex tasks all at the same time.
Exactly, like juggling a bunch of different projects simultaneously. And the paper we're looking at today, it's titled Everything Everywhere All at Once. LLMs can, in context, learn multiple tasks in superposition.
Catchy title. We already know that LLMs can do in-context learning.
Like with those few-shot learning examples, you feed it a couple of addition problems and bam, it can solve new ones it's never seen.
Exactly. So in-context learning is the baseline, right? Now, these researchers took that a step further and wondered, what if we throw a whole bunch of different tasks at these LLMs? Instead of just addition, maybe mix in some translation, or even something like identifying historical figures.
So instead of a nice, neat lesson plan, they basically threw a curveball at the LLMs. Interesting approach.
And what's fascinating is that the LLMs were actually pretty good at handling this chaotic mix of information.
Really? So they could switch gears between, say, solving a math problem and translating a sentence all in one go.
You got it. They were processing and executing instructions from completely different tasks, all within a single request. It's pretty remarkable when you think about it.
That is wild. Instead of just getting the answer to 2 plus 2 equals round, it could also tell me what that equation is in Spanish or something.
Exactly. And sometimes it would even get even more creative. Instead of just giving the numerical answer, it might spit out the answer and then its French translation all in one go.
Okay.
And the researchers weren't just working with one type of LLM either. They tested this with different families like Llama and GPT 3.5 and found evidence of this task superposition behavior across the board.
So it's not just one fancy model pulling this off. It seems to be a more widespread capability.
It does seem that way. They really wanted to see if there was a limit. They even started throwing in tasks that require completely different types of reasoning.
Are we talking about an LLM composing a symphony while simultaneously playing a game of chess, all while writing a novel? Because that's where my mind's going with this.
Hold your horses. It's not quite at that level yet. There are still some limitations, but the research did uncover an interesting pattern. Size seems to matter.
Bigger is better.
It seems so. Larger LLMs were much better at juggling multiple tasks at once. Plus, they were better at adjusting their responses based on how many examples they got for each task.
So it's not just about how much they can handle, but also how well they can adapt to what you're asking them to do.
Exactly. That adaptability, that calibration to the task at hand, got better with size too. Smaller models were a bit more biased. They had their preferences, even if you gave them an equal mix of examples.
Okay, but this whole thing still feels like a magic trick. How are these LLMs actually doing this? Do the researchers have any theories about what's happening under the hood?
They do, and it all comes down to something called task vectors. Basically, these are internal representations within the LLM that seem to encode the instructions for different tasks. Imagine them like cheat sheets the LLM uses to figure out what you're asking.
Okay, so each task, like addition or translation, has its own cheat sheet. But how does that explain the multitasking?
Here's where things get really interesting. The researchers found evidence that when you give an LLM multiple tasks, it might actually be combining these task vectors, creating a sort of hybrid cheat sheet.
So not just switching between cheat sheets, but actually blending them together. That's wild.
And to test this idea, they got a little crafty and tried manually combining these task vectors. Basically, they were creating their own blends to see if they could artificially induce this task superposition effect.
So like hacking into the LLM's brain and making it multitask on demand.
Let's just say the results are pretty interesting. It was pretty wild. They found that they could actually get the LLM to produce outputs that looked a lot like task superposition just by messing with these task vector blends.
Hold on, you're talking about blending these task vectors as if it's as simple as mixing a cocktail. What does that even mean practically?
No, you're right. It's not that complicated. It's basically, imagine you have those cheat sheets we were talking about. One for copy the first number, another for copy the second number. Blending them is like taking a weighted average of those cheat sheets.
Okay, so the weights determine how much of each cheat sheet is in the mix. So a 50-50 blend would mean the LLM is equally likely to copy either number.
Exactly. And when they tested this, it actually worked. By adjusting the weights, they could influence what the LLM spat out, just like when it was doing the task superposition thing naturally.
So they're basically controlling the LLM by tweaking these internal representations, like finding a control panel for its brain or something.
Yeah, that's a good way to put it. But there is a but, and it's a pretty interesting one. While manually combining the task vectors did produce outputs that looked like task superposition, it wasn't a perfect match.
What do you mean? How is it different?
For one, the LLM got a bit messier in its output when it was working with those artificially blended task vectors. Sometimes it would spit out stuff that wasn't really relevant to any of the tasks it was given.
Less elegant multitasking, more random gibberish, trying to speak a language that's a mix of French and Klingon.
That's a pretty hilarious way to put it, but yeah. And that little quirk suggests there's more to task superposition than just adding and subtracting task vectors. Something else is going on in that LLM brain that we haven't quite figured out.
Interesting. This hidden talent is there, but we haven't quite figured out all the tricks yet. You mentioned earlier that bigger models seemed better at multitasking. Did the research find anything else about that connection between size and this superposition ability?
They did. It turns out that as models get larger, they seem to become much more sensitive to the instructions you give them. Remember how we were talking about the model adjusting its responses based on how many examples it gets for each task?
Show it more addition problems, it's more likely to give you a sum.
Exactly. That ability, what they call calibration, also got better as the models got larger. The smaller models tended to have their own biases, like they preferred some tasks over others, even if you gave them an equal mix of examples.
So the little guys are picky eaters, and the bigger ones are ready to tackle whatever you throw at them.
Huh. That's a good way to think about it. But this thing about calibration is really important because it suggests that as LLMs grow and become more complex, they're getting much better at understanding the nuances of what we're asking. Imagine being able to say, hey, I need you 80% focused on this report and 20% brainstorming ideas on the side. And the AI can actually do that. That's the kind of control this research is hinting at.
That would be incredible. Having an assistant that can not only juggle multiple tasks, but also adjust its focus on the fly, that sounds amazing. Do you think we'll ever get to a point where LLMs can seamlessly switch between tasks like a human assistant? No hiccups, no glitches, just smooth sailing.
It's definitely possible. But there's still some hurdles to overcome. The researchers actually pointed out some limitations in their work.
Okay, so we're talking about some seriously cool possibilities with this task superposition thing, but I get the feeling it's not all smooth sailing just yet. What kind of limitations did the researchers come up against?
Yeah, so one of the big ones they hit was this thing called generation collapse. Basically, while the LLMs could start off juggling different tasks, once they actually began generating output, they'd get stuck on one task at a time.
It's like they get so focused on one thing that they completely forget about everything else. You sit down to write a to-do list and end up drafting a whole poem about a coffee stain.
Yeah, that's a pretty good analogy. It's like they lose sight of the bigger picture, the other tasks they're supposed to be working on.
I see. So it's not that they can't handle multiple tasks at once. It's more about how they're actually expressing themselves.
And it makes sense when you think about it, right? The way most LLMs work now, they're mostly text-based and generate output one word at a time. So once they start down one path, it's tough for them to switch gears and start generating something completely different.
Makes sense. So where do we go from here? Is this generation collapse a deal breaker, or do the researchers see a way around it?
Oh, they were actually pretty optimistic. They even pointed to some promising avenues for future research.
Like what?
One idea they had was to come up with new decoding algorithms that would actually allow LLMs to maintain that multitasking ability throughout the whole process of generating a response.
Instead of forcing the LLM to spit everything out in one big jumbled mess, we need to find a way for it to create multiple parallel outputs, each one specific to a particular task.
You got it. And there's already some exciting work happening in this area. Actually, we've linked to a paper in the notes about a new algorithm called superposed decoding, which is mind-blowing in itself. It's not a perfect solution yet, but it gives you an idea of where things are headed.
Wow, it's amazing to think that we've gone from chatbots that could barely string a sentence together to LLMs that might be able to handle all these complex tasks at once. It feels like we're on the cusp of something massive here.
Totally. And honestly, what gets me most excited is that we're just scratching the surface here. If LLMs can already do all this, even with the limitations, imagine what the future holds. As we keep refining these models, finding new ways to interact with them, who knows what we might unlock?
It's both exciting and a little daunting at the same time. But hey, that's the world of AI for you, right? Always pushing boundaries. So if there was one mind-blowing takeaway you want to leave our listeners with today, what would it be?
That's a good question. I think for me, the biggest mind bender is how this research forces us to rethink things. We're talking about the potential for AI that doesn't just imitate what we do, but actually goes beyond, surpasses us in ways we can't even grasp yet.
A future where AI doesn't just help us with tasks, but helps us redefine what's possible. That's a future I'm definitely here for.